Number 1D says the density of bacteria in the petri dish for 1 to 4, radius 1 to 4, is modeled by the function g. And g of r, g as a function of the radius, is 2 minus 16 bracket cosine of 1.57 square root r of the cosine cubed. And so it says, for what value of k from 1 to 4 is g of k equal to the average value of g of r on the interval? So first of all, this is an average value problem. Okay, so we need, in this average value, essentially the mean value theorem in reverse. So we need to find the average value first. So that's the first thing. So I'm going to make sure I know the average value formula. Okay, so the average value formula looks like this. So average value is equal to 1 over the interval width times the area under that interval. And this is going to give me the average value of f of x. Okay, so average value, I'm just going to put in here brackets, f of x. So I've drawn the graph of g. In this case, we're going to do the average value of g. And I want to find the average value of this function by integrating it and dividing it by its interval width. So the average value of g of r is equal to 1 over 4 minus 1 in the integral from 1 to 4 of g of r dr. Okay, now this can't be integrated, or sorry, can't be anti-differentiated, so we need our graphing calculator for this. So I've graphed the graph here of g of r, and I'm going to integrate this function. And when I integrate this function, I end up with 29. This is going to work out to be 29, the area under that curve. So this area that I'm shading here, this area works out to be 29.6274 something. Okay, so 6274, and then I want to divide that value by 3. So I'm going to take that value of divide that by 3, and the average value of the g function works out to be 9.8758 approximately. Okay, so if I were to graph that then, so 9.8758, I'm just going to put that into my graph, and when I see the graph of this, I should be able to see that this line, this average value, does seem like it's a reasonable average value. So when I sketch this graph, it looks like it's, cuts in somewhere around here. Oops. It's going to cut in somewhere around here. Okay, and it should give me an average value between 1 and 4 that's going to be about the same. Okay? So that's my average value. Once I've solved for the average value, the second part of this is I need to find where the function, the g of r, is equal to that average value of 9.8758. And this is then equal to our g of r function. And we could solve this algebraically really, but we're gonna just plug it into our calculator and work this out. Okay, now we could solve for k because we can just undo this entire equation. There's nothing really that is complicated about this. We just need to undo with plus and divide, cube root, arc cos, divide again, and then squared. So we can undo it that way, but we can also just graph it, and I'm just going to graph it and find the intersection of those two graphs. And this gives me a value of approximately 2.4970. Okay, so our R value works out to be 2.4970, and that's in centimeters. And this represents, really, sorry, I should state that this is K. So K value is equal to that.